Hello everyone, welcome to TESPERT MBA Prep. So this is the part 2 of time, speed and distance. If you haven't watched part 1 of this, we suggest you to watch that video and come back to this. So our agenda to this session is we'll look into the concept of trains. After that we will solve some examples and also delve into the different cases that are involved in the concept of trains. After that, we'll move on to boats and streams, and then we'll look into different cases and we'll solve different examples. So let us start with the concept of trains. So before solving this question, I will brief you about the concept of trains. In trains, we have two cases basically. The first one is stationary body, which is a body which doesn't have motion, right, any movement. And the second case is moving body. And in the first case we have two more cases. The first one is the point object, where the train passes a point object, and in the second case we have object with a definite length. Same goes with moving body case as well. So in moving body case, the point object moves towards the train or moves along with the train, as well as in the object with certain length case, the object either moves towards the train or moves along with the train. We'll take one by one here. We'll take this case, we'll take this and this, right? Now a stationary body which is a point object. Let's take this is an object, this is a point object. And when do we say the process of crossing started and when do we say the process of crossing ended? Let's take a train here. So let's consider this as a pole, not just a point. Of course, pole is also a point object because the distance is negligible. Okay, so this is the rear end of the train. This is the rear end of the train. This is the front end of the train. Alright, when the front end of the train touches the pole, then we say that the process of crossing started. So after this, the train will be like this. This will be the front end and this will be the rear end. And now we can say that the process of crossing ended because the rear end is now here, right? It shifted its place from here to here, right? Now if we observe here, the train moved the distance same that of its actual length, right? If someone asks you how much distance did this train travel, then you will say that the distance of train is equal to the length of the train in this case. Now let's solve this example. A train of length 300 meters crosses a pole in 1 minute. What is the speed of the train? So as we know, when it crosses a pole, then the distance is negligible. Then the distance covered is equal to the length of the train. So what is the relation? Speed is equal to distance by time. And distance is given, that is 300 meters, by time is given, which is 1 minute, that is 60 seconds. So this is 5 meter per second. So this is the speed of the train. Now let's take the second case, that is the stationary body with a definite length. Now let's say this is a platform, right? So the length of the platform is represented as LP. Now this is a train and the length of this train is represented as LT. Now when this train crosses this platform, and after crossing, the position of the train is here, right? Now if I ask you the distance traveled by train, the train traveled this distance, it has traveled this distance plus this distance. So this is LP and this is LT, so the train has traveled LP plus LT. This is the distance traveled by the train. Now let's solve this example. A train of length 200 meters crosses a platform in 14 seconds. If the speed of the train is 25 meter per second, what is the length of the platform? Yes, we have the distance, distance of the length of the train, right? But the distance is equal to length of the train plus length of the platform. But we know only length of the train, so 200 plus length of the platform, let us assume it to be x. All right, and we know the speed as 25 meter per second. So calculate, so time is equal to distance by speed. Time we know 14 seconds, right? So 14 seconds is equal to 200 plus x, and so speed will be equal to 25. So solve it and we'll get x as 150 meters. So the length of the platform is 150 meters. Let's move on to the third case, which is moving point object. Moving point object. Okay. So as this is a moving case, the concept of relative speed comes into picture, right? Here there is a point object. Let's take it can be a point, it can be a man, or it can be a pole. Let's take this one as man, right? So he's a man. He's moving in this direction, whereas this is a train. This is moving in this direction. Now the distance covered by the train is the length of the train itself, because this is a point object and the length of this object is negligible. One thing here to note is, when it comes to relative speed, as they are moving in opposite direction, the relative speed gets added. Let's take the speed of this man is u and speed of this train is v. The relative speed of man and train is u plus v, because they are moving in opposite direction. If this train is also moving in the same direction like this along with the man, the relative speed will be u minus v. Now let us answer this question. Let us solve this. A train of length 240 meters is traveling at a speed of 35 meter per second. If the train takes 6 seconds to cross a cyclist who is traveling towards the train, what is the speed of the cyclist? Alright, so here the distance is given. Distance of train is 240 meters and the speed is 35 meter per second, and here the cyclist is traveling towards the train. What does this mean? Towards the train means opposite, right? If this is train, this is the cyclist, and cyclist is traveling towards the train. As they are moving towards each other, the speeds of the respective speeds get added. So 35 plus, we don't know the speed of the cyclist, so let it be speed as c. So speed of the cyclist. We know time is equal to 6 seconds. So time is equal to distance by speed, that is 35 plus, yes, c, speed of the cyclist, that is the relative speed. So speed of the cyclist is equal to 5 meter per second. Let's move on to the last case, which is moving object with a definite length. So let's take, this is train 1 and this one as train 2. Now the length of train 1 is 300 meters, whereas the length of train 2 is meters. The speed of train 1 is 35 meter per second, whereas the speed of train 2 is 25 meter per second. Now my question to you is, how much time does the faster train take to overtake the slower train? So how much time does the faster train take to overtake the slower train? Here if we observe the distance and the direction, I didn't mention here, sorry. Train 1 is moving along with train 2, so the direction is same. So if the direction is same as we discussed in the previous slide, we must add the direction. So here if we consider the distance, the total distance is the sum of both the trains, that is 300 plus 200 meters. What about speed? Relative speed. As they are moving towards the same direction, moving in the same direction, the relative speed will be 35 minus 25. So we have to subtract them. If they are moving in opposite direction, we have to add them, right? So total time will be distance by speed. Distance in this case is 500 by speed is 10. So this will be 50 seconds. So the faster train takes 50 seconds to overtake the slower train. Now let's take this example now. Two trains A and B of length 200 meters and 250 meters respectively take 20 seconds to cross each other. When they cross each other in the opposite direction, the faster of the two trains takes 60 seconds to overtake the slower train. What is the speed of the faster train? Okay. So here we have two cases, case 1 and case 2. In the first case we have the opposite direction, and in the second case we have same direction. So what about opposite direction? Here speed is not given. Speed of the faster train is not given, as well as the slower train is also not given. So let it be S, speed of the faster train be SF and speed of the slower train be SS. So in opposite direction, as we already discussed, we have to add the values of the speeds in order to calculate the relative speed. So SF plus SS. And in the second case, where the trains are moving in the same direction, we have to subtract the speed of faster train with the speed of the slower train. Now the distance is same. Distance that they are covering is 200 plus 250, that is 450. So the length of the train is equal to the total distance. And time in the first case is 20 seconds and time in the second case is 60 seconds. Be careful, be very careful with the values here. It is in seconds. So it is in seconds, and 450 is in meters, so meter per second, there is no issue at all. If it were in kilometer per hour, then you must convert that into meter per second, right? Now, so time is so time is equal to 20 is equal to distance by speed. Speed is SF plus SS in the first case, and this will be equal to SF plus SS. This will be equal to 45 by 2. This is the equation 1. In second case, time is equal to distance, that is 450 by speed SF minus SS. So speed of the faster train minus speed of the slower train is equal to 45 by 6. Now if we add equation 1 and equation 2, we can find out the speed of faster train. Let me add it here. See, when we add speed of slower train and plus and minus get cancelled, so we are left with speed of 2 SF will be equal to 45 by 2 plus 45 by 6. So speed of the faster train is equal to 15 meter per second. Train concept, other terms of opposite, right? When two trains are in opposite direction, so instead of giving opposite, we may also be given as crosses, right? Train 1 crosses train 2, or train 2 crosses train 1, or train 1 and train 2 proceeds towards each other. So all these terms are same, right? So crosses, and train 1 crosses train 2, or train 1 proceeds towards each other. So these and along with opposite, these three are same. Whereas if we consider parallel, like trains are moving in a parallel direction, right? So parallel is synonymous to overtake, like train 1 overtakes train 2, right? So generally overtake, the concept of overtaking comes when two vehicles are traveling towards traveling along the direction, right? So we must understand this. We shouldn't get confused. So two stations A and B are 110 kilometers apart on a straight line. One train starts from A at 7 a.m. and travels towards B at 20 km per hour. Another train starts from B at 8 a.m. and travels towards A at a speed of 25 km per hour. Okay, at what time will they meet? So here let us assume that they will meet X hours after 7 a.m. right? Let it be X hours. So distance traveled by A in this x hours is speed into time, right? What is speed of A? Is 20. What is time? X. 20x. So this is the distance covered by A. Because A started at 7 a.m. B started at 8 a.m. So A started earlier than B. Now distance covered by B will be the time that B takes is x minus 1, not x, because B is 1 hour late. After 1 hour B started, right? So this will be equal to, what is the speed of B? 25 kilometer per hour, and the time is x minus 1. This is the distance of B covered by B. Now if we observe, two stations A and B are 110 kilometers, right? So two stations A and B are 110 kilometers apart on a straight line. Okay, so two stations, this is station A and this is station B, they are apart. So what's the distance between them? 110 kilometers. Alright. So one train starts from A at 7 a.m. So this is train 1 and this is train 2. It starts at 7 a.m. here, 7 a.m. and travels towards B at 20 kilometer per hour. So the speed is 20 kilometer per hour. Another train B starts at 8 p.m. So this one from B, this train starts at 8 a.m. and travels towards A. Understood? Towards A means they are traveling in opposite direction, and the speed of this train is 25 kilometer per hour. Okay, so we are asked to find out the time, at what time will they meet. So let us assume that the total time, so they will meet x hours after 7 a.m. So as train 1 starts at 7 a.m, they meet at some point of time after 7 a.m, the two x hours. Okay, let the time be x hours, right? So now the distance covered by A is, A in x hours is, distance is speed into time. What is speed of A? Speed of A is 20 km/h and the time is x, so 20 into x, this is the distance covered by A. Now distance covered by B will be equal to, what is speed of B? 25 into what is time? X minus 1. Why minus 1? Because train 1 started from A at 7 a.m. whereas train 2 started from B after 1 hour. So we have to subtract minus 1, subtract 1. So this is dA means distance traveled by the first train from A, whereas dB means distance traveled by the second train from B. So as we know that the distance between A and B is 110 kilometers, we can equate these two. So this one plus this one will be equal to 110 kilometers. That is 20x plus 25 into x minus 1 will be equal to 110. Calculate this, we'll get x as 3. So 3 means from 7 a.m. So 7 a.m. plus 3 hours, this will be equal to 10 a.m. So at 10 a.m. the two trains meet. This problem by an alternative method instead of doing all these calculations. So this is station A, this is station B. Now the first train started at 7 a.m. The second train started at 8 a.m. Now the difference is 1 hour. So in this 1 hour, the first train should have traveled 20 kilometers. So it started here and it reached here, right? After this, after reaching 20 kilometers, the journey of second train begins, right? So the distance between these two stations is 110 kilometers, and out of this 110 kilometers, already 20 kilometers are covered by A, by train 1, right? So the remaining is 90 kilometers. Now this 90 kilometers will be covered by both train A and train B, right? They are moving in opposite direction. Just apply the relative speed concept. Now the distance is 90. We have to find out time. So time is distance by speed. What is speed? Speed is speed of train 1 is 20 and speed of train 2 is 25. So 20 plus 25y plus because they are moving in opposite direction. So 90 by 45, this is equal to 2. What is 2? 8 plus 2. 8 am plus 2. So this will be 10 am. This is easier, right? This is easier than the previous method. So if we apply the relative speed concept, this will be more easier to solve these kind of problems. So let's take this problem as well. So two trains, each 100 meters long, moving in opposite directions, cross each other in 8 seconds. If then the speed of the faster train is. So let us assume the speed of the slower train be x meter per second. And what is the speed of faster train? As we can see, if the one is twice as fast as the other, then the speed of the faster train will be 2x meter per second. Now as they are moving in opposite direction, the relative speed will be 2x plus x, right? This will be 3x meter per second. Now what is the distance here? Two trains, each 100 meters long. So train 1 is 100 meters, train 2 is 100 meters, so the total length is 200 meters. This is the total length, this is also the total distance. So distance by what is the time? Time is 8 seconds. This will be equal to speed is 3x. So x will be equal to 25 by 3. So substitute this here, we'll get the value of the speed of faster train. So the speed of faster train is 50 by 3 meter per second. Let's look into one more problem. Two trains of equal lengths take 10 seconds and 15 seconds respectively to cross a telegraph post. If the length of each train be 120 meters, in what time in seconds will they cross each other traveling in opposite direction? If we observe here, the what is the speed of the first train? Distance by time, right? So speed of the first train is, the length of each train is 120, so distance is 120 by the time of the time taken by the first train is 10 seconds. So the speed of train 1 is 12 meter per second, whereas the speed of the second train is also 120 by what is the time? 15. This will be equal to 8 meter per second. Now what is the relative speed? As they are moving in opposite direction, the relative speed will be 12 plus 8 because we have to add them. So this relative speed is 10 meter per second. That means for every second the both trains travel 20 meters. So the required time is, so time will be equal to distance by speed. What is distance? 120 plus 120, which is 240 by speed. Speed is 20. So this will be equal to 12 seconds. Okay, let's move on to the next one. A train overtakes two persons walking along a railway track. The first one walks at 4.5 km per hour. The second one walks at 5.4 km per hour. The train needs 8.4 and 8.5 seconds respectively to overtake them. What is the speed of the train if both the persons are walking in the same direction as the train? So if we observe here, this is the train. Let us assume this one to be train, and this is moving in this direction. Here is man 1 and here is the other man. So this is person 1, person 2. Alright. So the first one walks at 4.5 km per hour. So he walks at 4.5 km per hour, and the second person walks at 5.4 km per hour. And this train needs 8.4 kilometers and 8.4 seconds and 8.5 seconds respectively to overtake them. So they are also moving towards moving along with the train in the same direction. Now as this is in seconds, we shall convert 4.5 kilometer per hour in seconds, meter per second. This will be equal to 4.5 into 5 by 18. So this will be equal to 1.25 meter per second. And we shall also convert 5.4 kilometer per hour into meter per second. This will be equal to 5.4 into 5 by 18. So this will be equal to 1.5 meter per second. So we do not know the speed of the train, so let the speed of the train be x meter per second, right? So now what is the relative speed here? Relative speed of this train with the first person and relative speed of the train with the second person. Relative speed is, as they are moving in same direction, we must subtract the speed of the train minus speed of the first person, that is 1.25 meter per second, speed of the train minus speed of the second person, that is 1.5 meter per second. So this is speed, and the time is 8.4 for the first case and 8.5 for the second case. Now if we multiply these two values, 8.4 into x minus 1.25 and 8.5 into x minus 1.5, then we will get the distance, right? Speed into time. So speed into time, so we will get the distance in both the cases. So let's multiply and equate them so that we'll get the value of x. So 8.4x minus 10.5 will be equal to 8.5x minus 12.75. So calculate this and we'll get x as 22.5. So this is the speed of the train, but we must express this in kilometer per hour, right? So if we want to express this in kilometer per hour, we can just multiply this with 18 by 5. This will be equal to 81 kilometer per hour. So now we shall learn about boats and streams. This is a new concept. So in boats and streams, we have some terms like upstream. The second one is downstream. The third term is the boat speed of the boat, and the fourth one is the speed of the stream. And we also have something called still water, right? What is still water? So if the speed of the water is 0, so if the water is stationary, if it's not moving like in a lake, right, then it is known as still water. So what is meant by stream? The speed of water, right? The moving water in a river is known as a stream. Here we have upstream and downstream. Upstream means if a boat or someone, if a boat or a swimmer moves in opposite direction of the stream, like if the stream is in this direction and the boat is traveling in this direction, if they are opposite, then it is known as upstream. So in downstream, the direction of the boat as well as the direction of the swimmer or the direction of the stream is same direction, simultaneous, parallelly, right? And in some problems where the speed or the speed of a boat is generally given, so it usually means the speed in still water. So if in a question it's mentioned like the speed of boat is 5 km per hour, then what does this mean? The speed of the boat in still water is 5 km per hour. So here in upstream, what is the relative velocity? See, in train problems, what did we do? We if both trains are traveling opposite to each other, then we added the speeds of both the trains. We added. But in this case, where the stream and the boat are opposite in direction, we have to subtract the speeds. Why? Because the stream is in this direction and the swimmer or the boat is in the opposite direction, then some negative energy, the negative work is done. So because of that, we have to subtract. And in downstream, what happens is the speed of the direction of the stream is in this direction, and also the direction of the boat is also in this direction, so the speeds get added. Why? Because the speed of the stream helps the boat to travel more quicker. Because of that, we must add the speeds. So the speed of upstream is calculated as speed of boat minus speed of the stream, and in downstream case the speed of boat plus speed of stream. So what about boat speed? Boat speed, we have a formula to calculate boat speed directly, that is upstream speed plus downstream speed by 2, and we can also calculate stream speed by using this formula, which is upstream minus downstream by 2, the speed of upstream and speed of downstream by 2. But how did we arrive with these equations, with this formulae? U plus d by 2, u minus d by 2. Of course, it is easy to remember, so as because there are no complications. But how did we arrive? So let's say, as we know, the speed of upstream is b minus s, and the speed of the downstream is b plus s. If we add these two, what do we get? U plus d will be equal to 2b. So b will be equal to u plus d by 2. Got it? Same goes with this one as well, right? So remember this, make a note of this. This will be very handy while solving problems related to boats and streams. Let's move on to the first question. See, the speed of a current is 5 km per hour. A motor boat goes 10 kilometers upstream and back again to starting point in 50 minutes. The speed in kilometer per hour of the motor boat in still water is. So this is a river, right? So the speed of the current is 5 km per hour, and a motorboat goes 10 kilometers upstream. Upstream means opposite. So the motorboat is in this direction. This is the speed. This is the motorboat, and the distance traveled by the motorboat is 10 kilometers. So distance is constant. So distance is 10 kilometers. This is the distance. So it goes 10 kilometers upstream and back again to the starting point in 50 minutes. So the time is 50 minutes. This is the time. Of course, we will convert this into kilometer per hour later. So this distance is constant. The upstream distance and downstream distance both are constant. Both are 10 kilometers. Distance is same. Now the speed of the motorboat in still water is. So we know the motorboat, the speed of the stream is 5 km per hour, but we do not know the speed of the motorboat. Let it be x. Now the relative speed as it is upstream is x minus 5 in upstream and x plus 5 in downstream. Now time will be equal to distance by speed in the upstream plus distance by speed in the downstream. So time we know 50 meters, but 50 minutes. So 50 by 60 to convert into hours. Distance in upstream is 10 by distance speed of the upstream is x minus 5, because we have to subtract both the values to get the relative speed, and distance is same in the second case as well, and speed varies, but because we have to add both the speeds x plus 5. Take LCM and calculate. We will arrive at a quadratic equation, which is 5x square minus 120x minus 125 will be equal to 0. So solve this. If we solve the quadratic equation, we will get x as 25 km per hour. But we can also do one more thing. Instead of solving this quadratic equation, we can proceed by looking into the options, right? Let's take 25 as option, right? If we take 25 as option, we can stop after writing this step, because we can substitute 25 in the place of x. If 50 by 60 is equal to 50 by 60, if both the LHS and RHS are equal, then that option is the correct option. Let's take 25 here. So 50 by 60 will be equal to 10 by x minus 5, that is 25 minus 5, that is 20, plus 10 by 25 plus 5, that is 30. So this will be equal to 60, 30 plus 20. So this will be equal to 50 by 60. So 50 by 60 is equal to 50 by 60. So 25 is the correct option. So If you feel solving quadratic equation as a lengthier process, then you can definitely try this method. Let's try the next question. What is the next one? A boat takes 26 hours of traveling downstream from point A to point B and coming back to point C midway between A and B. Alright, so if the velocity of the stream is 4 km per hour and the speed of the boat in still water is 10 km per hour, what is the distance traveled between A and B? So see here, a boat takes 26 hours for traveling downstream from point A to B. Okay, from point A to B, that to downstream, it takes 26 hours, and coming back to point C as well. Okay, so C is the midpoint here. This is C. This is the midway between A and B. Now from point A to point B it travels, and also it then moves from point B to point C. Now the total number of hours time taken is 26 hours. We know the speed of boat is 10 km per hour and the speed of the stream is 4 km per hour. Of course the velocity. So time taken is equal to distance by speed in the upstream, distance by speed in the downstream. So what is time here? Time is 26 hours. The distance is d by 2. D by 2 by 6. Why d by 2 here? Because in upstream the boat just traveled from B to C. In downstream it traveled the complete distance, right from A to B, but in upstream it just traveled from B to C. So that's why half of the distance is calculated, but in the second case the complete distance is calculated by the speed, that is 14. Why 14? We have to add, right? As they are moving in the same direction, as the stream and the speed of the boat are in same direction, we must add 10 plus 4. In this case we must subtract 10 minus 4. So this will be equal to 26 is equal to d by 12 plus d by 14, and take LCM and simplify this. We will get d as 168 kilometers. So the distance between A and B is 168 kilometers. A boat goes 6 kilometers an hour in still water. It takes thrice as much time in going the same distance against the current comparison. Okay, so the current comparison to the direction of the current, the speed of the current is alright. So what is the speed of the boat? Speed of the boat is 6 km per hour, right? 6 km per hour. But the speed of the stream is not given, so let us assume that to be x kilometer per hour, right? And if we observe here, it takes thrice as much time is going to the same direction against the current comparison. That means the upstream is equal to thrice that of the downstream. So upstream is equal to thrice that of the downstream. But what is the upstream here? So the time taken by upstream is equal to time taken by 3 times that of the time taken by downstream. So what is time here? Distance by speed. Distance by speed of the upstream is equal to 3 into distance by speed of the downstream. So speed of the downstream is equal to 3 into speed of the upstream. What is speed of the downstream? In downstream, as we know, we have to add the speeds, right? So 6 in the first case plus in second case it is x. This will be equal to 3 into speed of upstream. We have to subtract in case of upstream, so 6 minus x. So this will be 4x will be equal to 12. So x will be equal to 3 km per hour. So the speed of the current is 3 km per hour. See, we didn't do anything here. We just arrived at this equation and everything we applied is relative velocity, the relative speed concept. So a man can row 30 km downstream and return in a total of 8 hours if the speed of the boat in still water is 4 times the speed of the current, then the speed of the current is. So what is given here? The distance is given, right? A man can row 30 kilometers downstream and return. So in downstream and upstream, the distance is same. So distance is constant. So distance is 30 kilometers. And what about time? Time is 8 hours, right? Total of 8 hours. So he went to the downstream and also he returned, and the total time taken is 8 hours. So a boat covers 12 kilometers upstream and 18 kilometers downstream in 3 hours, while it covers 36 kilometers upstream and 24 kilometers downstream in 6.5 hours. So what is the speed of the current? Okay, so it seems to be a problem with two equations, right? Okay, let's solve this. So a boat covers 12 kilometers upstream. So 12 kilometers is the distance and 18 kilometers is the downstream, right? We don't know the speeds, right? So speed in upstream, we have to let the speeds of the upstream and downstream be x and y respectively. So x, y, this is the upstream, this is the downstream. So in upstream, what should we do? We should subtract x minus y, and here in downstream we must add the speeds, right? So what is time given? Time is 3 hours. So time will be equal to distance by speed. This is distance, this is speed, and this is speed. This is the time in the first case, this is time in the upstream, this is time in the downstream, this is the total time taken. And what about second case? It covers 36 kilometers upstream and 24 kilometers downstream in 6.5 hours. So 36 upstream, so x minus y, plus 24 downstream, x plus y. Total hours are 6.5 hours. So it will be 13/2 hours. Now what shall we do? This is equation 1 and this is equation 2. See, if we multiply the first equation with 3, we can cancel this one and this one, right? It becomes 36 by x minus y, so we can cancel. So if multiply this first equation with 3, so that it becomes 36 by x minus y, and we are left with, let me write it here, we will be left with 5/2, that is equal to 30 by x plus y. So x plus y will be equal to 12. Now if we place this in any one of the equations, we'll get x minus y, and then if we calculate, if we add both x plus y and x minus y, we are left with the respective values of x and y. So substitute x plus y is equal to 12 in equation 1. 12 by x minus y will be equal to 18 plus 18 by 12 will be equal to 3. Calculate this, take LCM, calculate this, we'll get x minus y as 8. So x plus y is equal to 12, x minus y is equal to 8. So 2x, so we are asked to find out the speed of the current, right? So 2y will be equal to 4, y will be equal to 2. So speed of the current is 2 km/h. Just remember the difference between the relative speeds that we calculate in train concept and the relative speed concept in boats and streams. In train concept, when two trains approach each other, that is when two trains move towards each other, move in opposite direction, we add the speeds. But in this case, in boats and streams, where the speed of the stream, where the flow of the stream is against the flow, the speed of the boat, we do not add, we subtract, because a negative work is done in that case. Whereas the direction of the boat and direction of stream are in the same direction, we will add the speeds, right? So just remember that. And in advanced arithmetic sessions, we will solve the difficult level problems, the moderate level problems, and in the next session we will look into the circular motion and the races, head starts, and we will finish the time, speed and distance concepts. So in case you haven't subscribed our YouTube channel, subscribe it and also press the bell icon so that you will never miss the updates. So keep revising, stay safe, all the very best. Thank you.